Welcome back, everyone. We're going to be solving LeetCode 323, number of connected components in an undirected graph. So we're given a graph of n nodes, and we are also given an integer n and an array edges, where edges of I is going to be equal to a of I, b of I, and it indicates that there is an edge between a and b in the graph. We need to return the number of connected components. So if we take a look at example 1, we have two connected components in this case, right? One is connected to 0 and 2, and then 3 is connected to 4. So we'd return 2 in this case. So we're going to solve this. I'm going to show you how to solve it using depth first and breadth first, just because it's not that big of a difference between the two, code-wise anyways. So what do we have to do? We're given a list of edges. That means we have to build a graph, right? So we'll say our graph is going to be equal to an empty dictionary. And we will loop through our edges. So for edge in edges, we will grab a and b, and we will say if a is not in our graph, we will add it. So graph of a will equal an empty list, right? We're building an adjacency list. So if b is not in our graph, add it. Graph of b will equal an empty list. And we will add those connections. So graph of a dot append b, and graph of b dot append a. So let's print this out, see what we have. Perfect. Now we have our adjacency list built. Now what do we need to do? Well, now we're going to need some sort of variable to hold the count of all of our connected components, right? So let's make that. We'll say count is going to be initialized to 0. Now there is a hidden test case in this problem, which is kind of annoying. So what we're going to have to do is if our graph is not equal to the length of the number of nodes that we have, then we're going to have to set our count equal to n minus the length of our graph. And that'll take care of that hidden test case. I think it's test case 27. So we'll say if the length of our graph is not equal to n, we are going to set our count equal to n minus the length of our graph. Okay, now we're going to run depth first on this. So we'll say stack is going to be equal to an empty array, and we will also have a visited set to keep track of all the nodes we have visited so far. Now we just need to loop through every vertice in our graph. So we'll say for vertex in our graph. If that vertex is not within our visited set, then we want to run depth first on that vertex. So we'll say if the vertex is not in our visited set, we want to run depth first. So we'll say stack.append that vertex. Let's get some more space down here so we can see what we're working with. All right, so we'll say if the vertex is not in our visited set, then we have to run depth first. So stack.append the vertex, and then while the length of our stack is not equal to 0, we will grab the current node that we are at by doing stack.pop. Now we need to loop through all of the neighbors of this current node. So we'll say for neighbor in graph of current, if that neighbor is not in our visited set, then we can append that neighbor onto our stack. And we'll also add that neighbor to our visited set. So we'll say visited.add the neighbor, and then we will say stack.append the neighbor. And then after we run this depth first search, then we can increase the count of our connected components, right? Every time we exit our depth first, that means we have found a connected component. So we can just increment our count right here after this while loop, and then we can return the count after this for loop exits. So let's run this. So this is looking pretty good. Yep, and we do pass both test cases, so let's submit. Awesome, and we do pass the submission cases. So, time and space complexity. Time complexity is going to be O of the number of vertices we have plus the number of edges we have, right? We have to traverse all of our vertexes and all of our edges, and the space complexity is going to be the same because we have to store the number of vertexes and the number of edges. All right, that'll do it for LeetCode 323.